You know that feeling when you're just drowning in information, notifications pinging constantly, emails piling up. Your brain feels like it's trying to drink from a fire hose.
That's a pretty perfect analogy for what's happening inside a lot of cybersecurity operations centers or SOCs today.
Right.
They're facing this absolutely explosive volume of potential threats, alerts, you name it. And at the same time, they're grappling with a major shortage of the skilled people they need to actually handle it all.
It sounds completely impossible. Like, how do you keep the digital fort safe when the alarms are just going off nonstop and you just don't have enough people on the battlements?
Exactly.
It's this real tension, isn't it, between the need for speed and scale, which, only technology can really bring, and the absolute necessity of human expertise, human judgment for making the right calls.
That's it. How do you navigate that? That's really the core challenge we've been diving into for you today.
So we've pulled together a whole stack of sources here, everything from a detailed academic review looking at the research on humans and automation working together in SOCs, to some frontline industry perspectives on where the rubber meets the road with automation challenges, and even some, practical breakdowns on calculating the return on investment, the ROI, for bringing in more tech.
Yeah, and our mission in this deep dive really is to cut through all that complexity and try to understand how organizations can genuinely combine the power of automation with those essential human skills in cybersecurity.
Because it's not about picking one over the other, right?
Absolutely not. It's figuring out how they team up effectively. That's the goal.
We're aiming to uncover some of those maybe surprising facts, bust a few myths perhaps, and deliver the practical insights you need to navigate this tricky landscape.
Definitely.
And real quick before we properly jump in, a big thank you to our sponsor, www.ratemysoc.com. They help you get a clearer picture of your SOC's performance, so check them out, www.ratemysoc.com.
Great resource.
Okay, so let's unpack this mountain of a problem. Where does this just overwhelming flood of alerts even come from?
Well, the absolute core issue, and this came up across basically all the sources, is alert fatigue. It's the sheer, almost unbelievable volume of notifications security analysts are expected to process.
Okay.
Get this. SOCs can receive an average of 12,000 security alerts every single day.
12,000 daily? That's just staggering. You can't possibly look at all of those manually.
You absolutely shouldn't even try. But the thing is, the manual investigation process for even just one alert is incredibly time-consuming.
How long are we talking?
On average, the sources show it takes over 30 minutes just to investigate one alert by hand. Now imagine scaling that up by thousands.
Right. And time is money, especially with highly skilled analysts. I think one source crunched the numbers on this.
Yeah, they did. Estimating that manually investigating just one alert could cost around $26.10 in analyst time.
$26 per alert. Multiply that by, even a fraction of 12,000. It's just not sustainable.
Not at all.
Yeah.
And it's not just actual verified threats contributing to that massive number either. A huge chunk of that noise, it comes from false positives and benign triggers.
Okay, so things that look bad but aren't.
Exactly. Alerts that fire based on rules but don't actually represent a real threat. Maybe systems or rules that are poorly configured, or sometimes systems optimized only to never miss anything.
Right.
They have a super low false negative rate.
Right, catch everything just in case.
But the downside is they end up throwing a ton of false alarms at the analysts.
Mm-hmm.
It's like having a smoke detector that goes off every single time you make toast. It just becomes noise.
Okay, yeah, that makes total sense. The cost of catching everything is this constant, unnecessary noise that actually drowns out the real danger.
Precisely. And then you add the complexity as the tool chain itself. There's something called tool overload.
Too many tools.
Way too many sometimes. Organizations buy dozens of different security tools, and just getting them to integrate, to talk to each other, and frankly, just keeping them running is this huge manual effort. One source pointed out that a single security tool can have over 200 APIs you might need to interact with. That's practically a whole job in itself, just managing the tools.
Wow. And I bet the tools aren't always smart enough to see the bigger picture either, right? Like, you might be investigating 3 different alerts that are actually all part of the same attack.
Exactly. But the tools present them as separate, completely unrelated events.
So the analyst has to connect the dots.
Right. The alerts often lack context, or maybe the context is spread across different tools, maybe in inconsistent formats. The analyst has to manually play detective, piecing together the timeline, the full story of a potential intrusion from all these different disparate sources.
So, okay, you're swimming in alerts, Tons of them are false alarms. You're wrestling with managing all these complex tools, manually connecting dots, and you're trying to do all of this while facing a significant shortage of skilled people.
Yeah, that's the kicker. 2 in 3 organizations say they don't have enough security staff. And we're heading towards a massive workforce gap globally in cyber.
Which just makes everything worse.
It just pours gasoline on the fire. The analysts you do have are completely overloaded with manual, often repetitive tasks, drowning in alerts. That alert fatigue gets even worse, and it seriously increases the chance that something critical, something really important gets missed.
So you put all that together, the volume, the complexity, the staff shortage, and suddenly automation stops sounding like some nice-to-have luxury.
And starts sounding like the only way to survive. It really does.
Yeah.
The sources consistently frame automation not just as beneficial, but as essential. A necessity to cope with the sheer scale and complexity of the modern threat landscape.
Okay, so it's essential. Where is automation actually making a difference? Like, where is it being applied effectively in the SOC today?
The academic research we looked at maps this out quite nicely, following the typical incident response lifecycle. It often starts with automated cyber threat intelligence, or CTI.
So dealing with threat feeds.
Exactly. Instead of analysts manually sifting through endless threat feeds, automation can consume that raw data, convert it into actionable intelligence, generate indicators of compromised IOCs, and automatically check those against your internal logs or alerts.
Okay, so it's like getting a head start. Knowing what bad stuff is out there and checking if you've already seen it internally. What about spotting things inside your own network?
That moves us into automated incident detection. This is where systems can help with things like alert correlation.
Connecting related alerts.
Yeah, connecting alerts that might fire from different tools but actually point to the same suspicious activity. They can also group or cluster similar alerts together, which helps reduce the noise, and automatically start gathering surrounding context as soon as an alert even fires.
And that context piece sounds crucial for the analyst.
Absolutely vital. Automated alert context is all about pulling in relevant information from across your environment data about the affected users, the specific machines or assets involved, maybe even linking it back to critical business processes. The goal is to provide insights like the potential impact and the risk level right there alongside the alert itself.
Which helps the analyst figure out what to prioritize, what they're actually looking at, much faster.
Exactly. And this then leads into automated alert reports. The idea here is to make the information more useful, more digestible for the human.
How so?
Well, automation can help structure the information and maybe create an intrusion storyline in a clear timeline format. Actually, the paper brought up an interesting distinction here. Interpretability versus explainability versus understandability.
Okay, lay that out for us. What's the difference?
Think of it like this. Interpretability is basically understanding what the alert is telling you. Okay, this is an alert about potential malware on this server. Simple enough. Explainability is understanding why the automated system flagged it. Okay, it flagged it because it saw process X spawning process Y in a way that matches a known malware signature, and that server talked to a known bad IP address just before. It's the reasoning.
Okay, the how it decided.
Right. And then understandability is about whether you, the human analyst, have the expertise and the background knowledge to actually make sense of that explanation and decide what to do next. So good automation helps with interpretability and explainability to ultimately improve the human's understandability.
That's a great way to put it. Not just telling you what, but why the machine thinks it's important. Okay, what about actually stopping the bad stuff, the response part?
Yeah, automated incident response.
Yeah.
This is maybe the most dynamic area right now. It can range from fairly simple decision support systems for known threats, where automation basically follows predefined playbooks, all the way to more adaptable systems designed for novel threats and dynamic response initiatives. We're seeing a lot of AI and machine learning solutions here, often packaged up in what they call SOR platforms, security orchestration, automation, and response.
Right, SOR. Heard a lot about that.
Yeah, and these platforms are being applied across the entire incident response process. They might help predict the severity of an incident, estimate how long it'll take to resolve, even automatically link related incidents together. You're also seeing tools being explicitly designed as co-pilots, which acknowledges that the tech's role is really to assist the human, not replace them.
Okay, so automation can really touch every single stage of handling a security incident. And the efficiency gains you mentioned earlier, they can be pretty eye-popping.
They absolutely can be. One source we looked at focused specifically on the ROI, the return on investment, for orchestration and automation. And they shared this truly stunning statistic. Automation can potentially slash the average response time for an alert from that manual 30 minutes down to just 5 minutes.
5 minutes. Down from 30. That's, what is that, an 83% reduction in the time and, crucially, the cost associated with handling each alert.
Right. Let's go back to that earlier example, that $26.10 per manual alert.
Yeah.
With automation dropping the time from 30 minutes to 5, that cost per alert could fall to around $4.35.
Yeah.
Now imagine the SOC handles, let's say, a conservative 100 actionable alerts a day. Manually, that's getting close to $1 million a year just in investigation time.
Wow.
With automation bringing that cost down so dramatically, well, the potential savings are huge. The ROI potential is very, very real.
Okay. That makes an incredibly compelling case for just throwing automation at the problem. But as always, there's got to be a catch, right? It's not just flip a switch and save millions.
Definitely not. No, the sources are pretty clear about the significant potential downsides if automation isn't implemented carefully. And the big ones that kept coming up are automation bias and complacency.
Automation bias and complacency. Okay, what does that actually look like in an SOC environment?
Well, it's basically the human tendency to over-rely on, or maybe just blindly trust, automated systems, even when they might be giving incorrect or maybe just suboptimal information.
So you just accept what the machine says?
Pretty much. You see the machine flag something, or maybe not flag something, and you just accept its judgment without applying your own critical thinking or seeking further context. And this is incredibly risky in cybersecurity.
Because you could miss things.
Exactly. It can lead to analysts missing critical alerts, ignoring them, or maybe just failing to investigate properly because the system didn't flag it strongly enough. Remember that earlier point about decision makers admitting they've missed or ignored alerts? Automation bias can be a big driver of that exact problem.
Wow. So the very thing designed to help you not miss stuff could actually make you more likely to miss it if you trust it too much. That's a problem.
It really is. And this ties into these concepts of misuse versus disuse of automation.
Misuse versus disuse. Okay.
So, misuse is that over-reliance we just talked about, treating the automated system as if it's infallible. Disuse is the opposite, purposefully neglecting or just not using the automation.
Why would you do that?
Well, maybe because of past negative experiences, maybe a lack of training, or maybe just not trusting the tool because you don't understand how it works. It feels like a black box.
Right.
And both are detrimental.
Right.
Disuse means you miss out on those vital efficiency gains we just discussed. But misuse exposes you to the system's errors, its blind spots, its biases.
Okay, so what kind of automation makes these issues, misuse or disuse, more likely? What are the red flags we should look out for in the tech itself?
The sources point to a few characteristics. One big one is that black box automation you just mentioned. Systems that lack transparency.
So you can't see how it works.
Exactly. If the analyst doesn't understand why the system flagged something, or maybe even more importantly, why it didn't flag something that their intuition says is suspicious, they're much less likely to trust it appropriately. And that can lead straight to either misuse or disuse.
Makes sense. What else?
Another issue is those systems we talked about earlier, the ones optimized only for incredibly low false negative rates.
The ones designed to never miss anything.
Right. While they're trying not to miss anything, they end up bombarding analysts with so many false alarms that it just contributes right back to that alert fatigue problem. And eventually that can lead to disuse. Analysts just start ignoring its output altogether.
It's like the system cries wolf so often the analysts just metaphorically unplug the speaker.
Exactly that. And one final point the research highlighted was systems that rely heavily on unsupervised learning models without necessary human oversight baked in.
Unsupervised learning?
Yeah, where the machine is learning patterns on its own from the data. The research mentioned examples where tools designed to spot anomalies could technically operate without any human interaction. But doing so potentially excludes crucial human judgment right when it's still needed, increasing that risk of bias or missing really nuanced threats that don't fit neat patterns.
So the goal isn't less automation then. It sounds like it's smarter automation. Automation designed to work with humans, not instead of them.
Precisely. And this is really where all the sources start to converge on this powerful central argument. Effective cybersecurity isn't about choosing automation or humans. The real strength, the real opportunity, lies in finding the optimal balance for effective collaboration.
It's that synergy, right? Leveraging what each side is best at. What are those unique strengths that the human analyst brings to the table that automation, no matter how smart it gets, still struggles to replicate?
Well, the human analyst brings crucial decision-making skills, first off. And that incredibly valuable tacit domain knowledge, the kind of expertise built up through years of experience, is just incredibly difficult to program into a machine.
The intuition.
That's a big part of it. They have context awareness, nuanced judgment, the ability to sort of read between the lines, understand geopolitical context maybe, or recognize subtle anomalies based on past events that were never formally logged or recorded. Humans are just better at handling those truly intuitive tasks.
And then building relationships.
Absolutely. Building trust and relationships,
Yeah.
which is vital, especially when dealing with third parties, like in supply chain security. But it's also important internally. The sources really emphasize thinking of the human analyst as the ultimate human as a security sensor. And technology should be designed to amplify their abilities, not replace or diminish them.
Amplify human capacity. I really like that framing. The academic paper we looked at introduced some concepts that really help structure this idea of balance, like the difference between degrees and levels of automation.
Yes, that's a really key distinction they make. Degrees of automation refers to the breadth. Basically, how many processes across that whole incident response lifecycle are automated? Is it just helping with detection, or does it also help with analysis, investigation, and response?
Okay, so breadth is how many things get automated. And levels of automation. That's about the depth within one of those processes.
Exactly. The level of autonomy the automated system has within a specific task. Does it just gather information for the human? Does it analyze and then recommend options? Does it maybe take action but require human approval first? Or at the highest level, does it take action autonomously and only inform the analyst after the fact?
Okay.
And the key point is you can have a high degree of automation, meaning lots of different tasks are assisted, but maybe low levels of automation within those tasks, where the human is still making all the final decisions. Or you could have the opposite. It's not just about automating more, it's about how you automate.
That distinction is really helpful, especially when you look at the SOC automation matrix the paper introduced. It helps visualize this.
It's a great framework, yeah. It helps visualize the different states of human automation collaboration by plotting the level of automation against the level of human involvement.
So can you walk us through those 4 quadrants?
Sure. Quadrant 1 is typically where most SOCs maybe start or perhaps currently reside. That's low automation plus high human.
Manual everything, basically.
Pretty much. Humans are doing almost everything manually. Now, they can be effective if you have really highly skilled analysts, but it's inherently inefficient because of that sheer volume and complexity we talked about. This quadrant is often characterized by the disuse of potential automation. Maybe it's not available, maybe it's not trusted, or just too hard to implement.
Right. Sounds exhausting and unsustainable, especially with that skills gap looming. So what's the worst place to be on this matrix?
That would definitely be quadrant 3, low automation plus low human. This is just ineffective and inefficient. You don't have enough automation to handle the volume, and you don't have enough skilled human analysts to compensate. Alert fatigue is critical here. Threats are absolutely being missed. You really need significant investment just to get out of this state.
Okay, so everyone wants more automation. Does that automatically mean jumping diagonally to high automation plus low human?
Well, that's quadrant 4. And it turns out SOCs often do aim here from Q1 simply by deploying lots of new automation tools.
Right, buy more tech.
Exactly. And it is efficient, no doubt, because the machines are doing things quickly. But, and this is crucial, it can be incredibly ineffective in its outcomes if that automation is prioritized ahead of skilled human judgment.
So this is where the bias and complacency really bite you.
This is exactly where you see that high risk of automation bias and complacency. The automation might have those problematic restrictive characteristics we discussed, being a black box, generating too many false positives. It's fast, yeah, but potentially wrong, or missing critical nuance.
So Q4 is efficient, but it's fragile and potentially ineffective, which leaves quadrant 2 as the sweet spot.
Absolutely. Quadrant 2 is the ideal state, high automation plus high human. This is where you have sufficient and crucially well-designed automation actively assisting highly skilled analysts. It makes their activities both effective and efficient.
The best of both worlds.
Think of it as a true team. Skilled analysts collaborating seamlessly with intelligent automated systems, each leveraging the unique strengths of the other. Tasks get done faster, more accurately, and analysts can then focus their time and energy on the high-value, complex, or intuitive work that only they can really do. This is a realization of effective socio-technical system design, optimizing the combined human and technical elements together.
So the real path to optimization isn't just adding automation and trying to reduce human involvement, like moving from Q1 straight to Q4.
Right.
It's about using automation to enable and amplify human involvement, moving from Q1 up to Q2. Or if you've accidentally landed in that risky Q4, it's about consciously adding back that critical human oversight and making sure that automation is actually supporting it, not overriding it.
Exactly right. It's not just about the amount of automation, the degrees, or even the autonomy of individual tools, the levels. It's fundamentally about how the automation is designed to interact with the human analyst.
What makes for good design then?
Well, the optimal systems described in the sources are typically those that provide comprehensive context alongside alerts, can explain or justify their decisions transparently, and crucially, they incorporate analyst feedback to learn and improve over time.
That feedback loop sounds important.
It is, which really drives home another critical point the sources emphasize. This isn't just a technology problem you can solve by buying the right tool. It's a people problem just as much.
Right. Implementing automation is a change initiative.
Absolutely. It's fundamentally a significant change management effort. As one source very wisely put it, organizations do not change, people do. You can buy the fanciest, most advanced tools in the world, but if the people who actually have to use them don't change how they work, or maybe they don't trust the tools or don't understand them, the whole initiative is likely to fail.
So focusing purely on the tech specs of the automation, the bells and whistles, isn't enough.
Not even close. It's vital to engage the analysts themselves throughout the entire process, involve them in pilots, get their feedback during the development and integration phases.
Because they know what they need.
They know what they need, and honestly, the automation is only truly effective if it's trained and programmed and guided by the very people who have that deep domain knowledge, especially your experienced Tier 3 analysts, who really understand the nuances the machines often miss.
So it sounds like it requires a truly holistic approach then, more than just installing software.
It absolutely does. It's not just a tech deployment project. It involves clear communication about why the change is happening, comprehensive training on how to use the new tools effectively and integrate them into existing workflows, and really importantly, creating ongoing feedback channels.
So analysts can flag issues?
Yeah, so they can flag issues, suggest improvements, and feel like they're partners in making the whole system better over time. That's how you build trust, that's how you get people comfortable, and that's ultimately how you move towards that ideal Q2 state of effective collaboration.
This whole deep dive has been incredibly illuminating. We started from that really overwhelming reality of alert fatigue, driven by just sheer volume, increasing complexity, tool sprawl, all that.
Then we saw how automation offers a necessary path forward, a way to handle that scale and unlock some really dramatic efficiency gains.
Right, those numbers were stark. But then we also uncovered the very real pitfalls, the risks of bias, of complacency, if that automation isn't designed with the human element squarely in mind from the start.
And I think the powerful takeaway, the synthesis from this stack of sources is really clear. The ultimate goal isn't just automating tasks for the sake of automation. It's about building truly effective socio-technical systems. Systems where the speed and power of automation are seamlessly integrated with the critical thinking, the nuanced judgment, and the invaluable context awareness of human analysts.
And understanding that distinction between the degrees of automation, how much is covered, and the levels, how autonomously it acts, that helps frame not just how much gets automated, but how the human and the machine actually collaborate within any specific process.
Exactly. And frameworks like that SOC automation matrix, they provide a practical map, a way for organizations to think about moving away from those overwhelmed or risky quadrants like Q1 or Q4 towards that high automation, high human collaboration ideal in Q2.
So as we wrap up this deep dive, it really leaves you with a significant thought, doesn't it? As automation continues its rapid evolution, as it becomes more and more capable, maybe the single most indispensable skill in cybersecurity isn't just mastering the machines themselves, but truly mastering the art of optimizing the unique strengths of the human mind working alongside them. How are organizations truly cultivating that synergy in your own operations?
That's a fascinating challenge, a critical one for anyone in this space to think about.
Indeed. And before we sign off, one final thank you to our sponsor, www.ratemysofc.com, helping you evaluate your SOC's performance and understand where you stand. That's www.ratemysofc.com.
Thanks again for tuning into this deep dive.
We really hope you feel more informed and maybe better equipped to navigate this crucial ongoing balance between automation and the essential human touch in cybersecurity.